Hi guys, you're welcome to God Academy. In this lesson, I'll be taking you through standard basis vectors and unit vectors. In our previous lesson, I took you through the introductory lesson to vector algebra as well as you saw some properties. If this is the first time you have been on this channel, please subscribe to get access to all the videos and also to support us. Don't forget to share to your friends. So in this lesson, I'll introduce what we call standard basis. Okay, these are special types of vectors called I, J, and K. Okay, and these have one common feature because they have a length of one. Okay, they have a distance of one, or we call them unit vectors. Okay, so standard basis I shows the direction. Okay, we can call them the fundamental vectors. Every vector can be expressed in this standard basis. Initially I showed you that we have you can have two-dimensional vectors, you can have three-dimensional vectors. If you have a two-dimensional vector, then it means that your standard basis will be I and J. But if you have three, it becomes I, J, K. Okay, let's define them. So in two-dimensional space, right? So in 2D space, let me say I'll have I to be equal to 0, 1. Sorry, in two-dimensional space, I'll have I to be 1, 0, okay, indicating the direction with respect to x. We have j to be equal to 0, 1, indicating the direction equal to y, okay. And in 3D space, I'll have I to be equal to 1, 0, 0, okay, j to be equal to 1, 0, 1, 0. Then finally z to be k to be equal to 0, 0, 1. So they indicate directions. That is why you can represent them this way. Have our x, we have our y, which is 1, right? Then we have our z, which is what? K, right? So we can have, sorry, ijk, that way. Any direction, but they are all perpendicular to each other, right? So these are standard bases and you'll be seeing them a lot, okay? You'll be seeing them a lot in the course of algebra. And as I said, they all have a unit distance of 1 and they form the basis for every vector. Any vector can be expressed in terms of I, J, and what? And K. Let's see something here. Our first example for this lesson. So it says that if A is equal to I plus 2J minus 3K and B is equal to 4I plus 7K, express the vector 2A plus 3B terms of I, J. So let's see. It says that if the vector A, which is I plus 2J minus 3K, and the vector B, which is 4I plus 7K, express the vector 2A plus 3B in terms of I, J, K. As simple as that. Let's see how we solve this. So to solve this problem, you know that A, you write A. So please, this ijk is simply coefficient, okay? You can extract it and you get 1, 2, -3 here. Then you can have B, which is equal to, your I stands for your first one, so 4. There is no J, so you have 0. Then there's K, right? You have 7. As simple as that. You know something? The reason why I'm not picturing this as a two-dimensional is because I have K. Once you have K, it means that you are in the third dimension. If there is no J appearing, then it means J is 0. Have that in your mind. So we have to find 2A plus what? 3B. What do we do? I'll simply have 2 multiplying 1, 2, -3 plus 3 multiplying 4, 0, and 7. This gives me 2 times 2, I'll have 4, 2 times -3, I have -6, right? Plus 3 multiplying this, I'll simply have this. 3 times 4 is 12, 3 times 0 is 0, 3 times 7 is 21. As simple as that. So 2 plus 12 is 14, 4 plus 0 is 0, Negative 6 plus 21 is 15. As simple as that. As simple as that. Right. Yeah, so this is actually how to solve this problem. And this is under standard basis. Let's talk about unit vectors. What are unit vectors? Unit vectors. So when you talk about unit vectors, we are dealing with vectors which has got a unit length of 1. Okay. Example is the I, J, and K vectors, which I showed you. Let's take I, which is 1, 0, 0 in the 3D, and find its length. So the length of I is simply be square root of what? 1 squared plus 0 squared plus 0 squared. This gives me square root of 1, which is 1. That means that's a distance of 1. So to find the unit vector of any vector, so actually you can find the unit vector in the direction of any vector. Okay, this is because you are trying to find a vector which has the same direction as the known vector but a magnitude of 1. How do we do that? It's given by the formula 1 over a. So let's say I have a vector a. Okay, a vector a. So the unit vector in the direction of a is 1 over the length of a times a itself. Therefore, I get a over itself and over the length of itself. So let's solve this problem. So find the unit vectors in the unit vector in the direction of the vector 2i minus j minus 2k. Then this is 1. I have another vector negative 3i plus 7j. And I have a third vector negative 4, 2, 4. As simple as that. So let's solve for the first one. So I have I 2i minus j minus 2k, right? So I'm to find the unit vector in the direction of this. Okay, so first of all, what do? I need to find the length. So you can equate this to a vector, a random vector p. So you need to find the length of p, and that will be equal to square root of 2 squared plus negative 1 squared for the negative j, the negative 2 squared. As simple as that. This gives us what? Square root of 2 is 4 plus 1, 5 plus 4, which is what? 9, right? Then that is giving us what? 3. Therefore, the unit vector is 1 out of 3 times 2i minus j minus, giving us 2 over 3i minus j over 3 minus 2 over 3k. That's that. Okay. So this is how you solve it. You can use the same thing for the second part, right? So my I or my second part will be what? Negative 3i plus 7k. Okay. So let's say this is Q. That you simply find the length of Q given as square root of negative 3 squared plus 7 squared. Square root of 9 plus 49 given as square root of 50. Okay. So you simply have 1 out of square root of 58 times negative 3i plus 7j. Can go further. I mean, just this is enough. Or if you want to expand, negative 3 over square root of 50i plus 7 over square root of 50. You can simplify square root of 50. So that is square root of 58. So, okay, so I mean, this is actually good. Last one is negative 424, right? Negative 424. You simply find the length, which is equal to the square root of what? Negative 4 squared plus 2 squared plus 4 squared. This gives us square root of what? 4 squared is negative 4 squared is 16 plus 4 plus 16, right? This is 32, 36, right? And that is equal to 6. Therefore, our answer is as straightforward as that. I have 1 out of 6. Then I'll have multiplying vector negative 4, 2, 4. So this gives us negative 4 over 6, 2 over 6, 4 over 6. That's equal to negative 2 over 3, 1 over 3, 2 over 3. As simple as that. Okay. So that is all for unit vectors. And let's see for dot products. But before that, I think I have a couple of problems here for us to go through. So I have determine if the sets of vectors are parallel or not. So I have A, which is equal to 2, negative 4, 1. I have B, which is equal to negative 6, 12, negative 3. Then I have the B. I have A, which is equal to 4, 10. I have B, which is equal to 2, negative 9. For two vectors to be parallel, one should be the scalar multiple of the other. They should be the same, just that one should be just a multiple of the other. Let's check here. When I come here, I have 2, negative 4, 1. When I come here, I have negative 6, 12, and negative 3. Right. Now, what do you do? This one appears to be in its simplest form. Don't use fractions. But here, I can factorize negative 3 out, right? I'll have negative 3 out. I'll have 2. It goes here 4, negative 4, and it goes here 1. And exactly what we have here, which is 2, negative 4, 1. But the only difference is that this is negative 3 times the other. Therefore, these vectors are said to be parallel. When I come here, I have 4 and 10. When I break it down, I have 2 out, I have 2, then 5. Is that not it? When I come to the B part, I have 2 and negative 9. Please, they are not the same. So these are not parallel. And that is all for this lesson. Please don't forget to subscribe, then you share.